There we go. Ready? What did I say right on top?
Solids.
Solids. Let's try this one more time. All right. Something's going to be up here. What? Ion going down. Or also known as geometric solids. And these are fun because they are three-dimensional. Something is using an unreal amount of my memory, because that's why this is not doing well. Any idea what it would be?
The rest of your video?
No. Which means simply this, children. When we talk about three-dimensional shapes, we have the shapes that fall under the category of polyhedrons. You will never ever use that word again. Maybe you will. Or they're called not polyhedrons. And probably the easiest way to think about this is shapes that have round things on them. And these are shapes that actually are made of all polygons. You remember the two things that it took to make a polygon? It had to be closed and it had to be straight lines. Does anybody remember that? Yeah, just saying that. And then under polyhedrons, we have these categories. I think you'll recognize these. We have pyramids. And, ladies and gentlemen, prisms. What is the difference between a pyramid and a prism? Anybody? Good. Pyramids come to a point, do they not? The great pyramids of Egypt look a little like this. Let me give you the best I can to draw one of these things. You can start with kind of like this shape. It's kind of supposed to be a square, but you need to draw a flat out if it's whatever it is. That's the base of it, our bottom thing. Put a point up here, and if you connect all of the vertices of the other one with that, you get that pyramid shape looking thing. A lot of times we put dash lines for lines we're not really supposed to see, but even though they're there. Or sometimes you may even shade them a little bit just to help give you a little bit of that side one color. Make this side another color. And that little shape there is called, because it has a square base, we call that a square pyramid. You can make a pyramid of just about any shape. For example, a hexagonal pyramid, what would that look like? Well, you'd have to start with a hexagon, kind of like a squashed hexagon like this. Put a little point up here and connect all those corners. Put a dash in there. Because the bottom is a hexagon, it's a hexagonal pyramid. Sometimes kids ooh and ah after I draw those. And the difference between a pyramid and a prism, a prism are like boxes and such. They don't come to points. They have parallel, anybody know how you spell parallel? Parallel, equal bases, which means nothing to you, doesn't it? Just say it doesn't.
It doesn't.
And I'm going to split this right here. So if I'm drawing a prism, let's say we're just doing a cereal box. What does a cereal box look like? Well, it's got this shape here. And if I draw an identical rectangle to that, let's say I draw it right here, and I'm going to draw it actually dashed, because it's going to end up being dashed. That one won't be dashed in the end, right? Same rectangle, connect the corresponding vertices, make this solid, make this solid. Can you see the rectangular prism there? This is where most people say this. You got the front of the box there, you got the right side of the box, and you have the top of the box. No points, I mean, it doesn't come to a point. This is a rectangular prism because it's made out of all rectangles. Versteh? You could do triangular prisms and they can be any way you want, just like see, you start with a triangle. If you draw an identical triangle back here and connect the vertices, you get a triangular, try to make it look like this, prism. Right?
Wait.
Still no ooh and ah. And now for my next path, we'll do an octagonal prism. Ready? 1, 2, 3, 4, 5, 6, 7, 8. I have to draw that same octagon right here. Let's see if I can do it. 1, 2, 3, 4, 5, 6, 7, 8. Does that look like one? Yes?
Yes.
No, no way. I'm gonna make this dashed. See if you can see this forming right before your very eyes. Now we will connect corresponding little vertices here. Ready? Connect this. Connect this. Connect this. Connect this. Connect this. We've got some dash lines here somewhere. Dash line. Dash line. Does anybody see it yet? Dash line. No, you don't. You will see it now once we put this little added touch here. This is one base. Here is another little side. Another side. Another side. And another side.
Ooh. Ah.
Looks a little like a drum, does it not? But it is a octagonal prism. Why isn't it called a rectangle? Isn't this shape a rectangle though? They are always named after whatever their base is. See, these are exactly the same as two octagons. That's why it's an octagon. Enough of that. Let's go back. So there are your polyhedrons. You've got the pyramids and you've got the prisms. Guess what the shapes that we have that are not the polyhedrons? Oh, they have round pieces to them. People, round is the key. No, they're not a circle. What's a circle thing called? Yes, we've got a sphere. We show that it's kind of a sphere by doing a little equator looking little dash line there. That's a sphere. You could also kind of shade it. The spheres are a little hard to draw. You can kind of shade it by drawing little circles around and little oval things. I'm trying to give it a little, leave like an opening there. The outsides are usually darkened quite deeply. That doesn't really look like the spirit of it.
Looks beautiful.
Oh, thank you.
Ooh. Should be in a museum. Yes.
Something like that. What else do we have that has round sides to it?
Circle.
How about a
Cylinder.
cylinder? And what about a cylinder that comes to a point?
Cone.
What do we call that? A cone. Which, by the way, you can make out of a cylinder by doing this. Check this out. Do the same trick a little bit. Put a little point right there. Draw this. Draw this. And there is the cone inside the cylinder. Isn't that handy? I forgot a couple things. Here's your cone. Some special types of prisms I need probably to throw out there at you. Well, one of them at least. Is this guy right here? If it's made up of all squares, or it looks like those little dice you use to play games, what do we call that? It is. It's a cube. Which is nothing more than a square prism. Do we have more? I don't know. I don't think I have time for this. Maybe we can do this here. Now, with this, let me go back to my cereal box. If you got your brother / sister a box of Wheaties for Christmas and needed to wrap it with wrapping paper, how in the world would you find out how much wrapping paper you need? Is that right? No. Did I do everything I need to do? How would I figure out how much wrapping paper I need, Aaron Ray? Let's say this is what's a cereal box. Maybe this is 12 inches by 3 inches by 10 inches high. No, it'd probably be higher than that one. Maybe 12 inches by 10 inches. You would have to find what we call its surface area. And surface area means the area of all the sides added together. Have we done this before? Anybody? So you'd have to know how many different sides are there to this box. Kind of, you can just take a seat for right now. You don't have to stand there, as much as I know you'd like to. If I were to cut the edges of this box and cut it out and unfold it, what would it look like? You've got this piece right here, right? The one that says Wheaties, correct? And then the part that everybody looks at when they're eating breakfast, which is the back side of the box, same rectangle, right? All right, we got this top up here, which connects it. Here's my top, and I got my back side. If I'm unfolding this box, it would look like that. And then I've got the bottom, right? What am I missing? These two little slivers here, right? This is the right side. And then this side over here is the left side, which would look like this. Right side, left side. If I was finding how much wrapping paper I would need to cover all of that, I would have to find the area of all the sides. And what would those areas be? Well, we know it's 3. All of these are 3s. all those little short lines. How tall is the box from here to here? All of these tall lines are 12s. And then how long are these width lines? Those are all 10s. So what is the area of this piece right here? Length times width is? But shout it out! Oh, one person knows. This is 30. How big is this? Anybody?
30.
Wow, there is somebody out there. What is this? Huh? Shout it out when you know the answer. What? Somebody's got that. Yeah, 3 times 12. This is 36. Guess what this is?
36.
Wow, we're making progress. And the only thing now I am missing are the Wheaties front part and the big part of the back, which would be what? 12 times 10 is? Yes, somebody said it. Say it out loud.
120.
120. And those are all square inches. To find the surface area, I would have to add all of those together. 2 120s, 2 36s, and 2 30s. Which in fact would give us, drum roll please, that sound right? 372, whatever, squares.
Yeah.
No, that is it. I guess it. Oh wait, so what's this? 6, 12, 13, 14, 15, 16, 17, 1, yeah, 370. You would need 372 square inches of wrapping paper to wrap up your Wheaties box there. How many people thought that was about